Kohsuke. I'm the creator of Jenkins. I currently work at CloudBees as an architect, and I assume, sounds like there is no need to introduce what Jenkins is, so I guess I'll skip that part. So one of the themes for me in doing Jenkins is that we wanted to shift more workload from your laptops and computers to the servers. I think that's a part of the motivation for doing this in the first place. But when we look at how successful we were in doing that, it's kind of somewhat questionable. It's a good thing that doing the continuous integration adds to more visibility. But one of the consequences is that now that the manager notices that a lot of the times builds are broken, people end up making sure that people end up running extra tests and so on to make sure that the depository isn't broken. So that results in having more test time on local computers, meaning more wait time for people. So so that's kind of a problem for me. That is, I ended up creating more workload for clients, not the server. So so that's why I guess the notion of pre-tested commit, I guess that was originally termed by JetBrains for TeamCity, was born. The idea was that, well, so let's run the test on the server before you commit it. And then so that's why the name is called pre-tested commit, meaning you've tested stuff before you committed it. So I guess the motivation for this feature should be pretty obvious, that you wanted to make changes more safely, because you do make mistakes occasionally, because we are all humans. But when that happens, we don't want that to block other people in the team, and so but we also wanted to run the test asynchronously, meaning, again, we don't want to use your laptops, the precious computer that occupy your attention, to be running heavyweight computing tasks that keeps you idle. And so, I mean, even with things like test-driven development, I think it's not practical to run the entire test suite on your computer. If you can push that onto some other nodes, that's better. And I guess another reason this is useful is not just the fact that the people make mistakes, but they tend to compound. Because, well, if you think about the simplified notion that every developer is making, let's say, 10% mistakes, so every 1 in 10 commit is bad, which is probably sounds like a reasonable rate. And as we add more people to the team, let's say if you have like 10 or 12, 20 people in the team, just by the math, you get this amazing, astonishing result that on average, I mean, the 80% or more time, you got some problem going on in the repository, and that would be disastrous. And so we have means to cope with things, like the modularizing these things help, the individually testing things would help, but again, at the same time, on the legacy projects, you can't easily do these things. So you get every help you can get out of everything, and then that includes the CI server. So I guess one way the others, if you look at the other example, like a ship, the way they design things is that they put the safety in the system. So even if the whole of the system is compromised in one place, they got these compartments in place that they don't, one hole wouldn't sink the ship. So, the solution for this kind of problem shouldn't be that everyone run tests as hard as they can and make sure there's no mistake. You want more systematic solution that doesn't depend on people working hard, right? So that's, I think, that's kind of the motivation for this area. And I think that's part of the reason why many people are interested in this area. So then back to this original idea of the pre-tested commits, meaning, running tests on the server before you commit. It turns out that, at least in my opinion, this is not exactly a bright idea, because you end up, this idea of sending back and forth the diff, that the change that you're considering to commit is actually a bit problematic in many ways. So, you have to think about where you keep them, both on the server side and client side, because while you're sending a test to the server, you want to work on something else. So, because you haven't committed this change yet, well, what are you going to do with that? Or oftentimes, you wanted to run the changes by other people. So this is somewhat tied to the notion of code review. I guess that's inherent in what we are doing here. But again, that doesn't work very well. And so, or while the server is running a test, you put this change aside, started working on something else, and then you learn that the test has broken, so you wanted to now switch back the context, and so shuffling these changes around. And if you start thinking about other file level operations, like creating a new file, deleting it, moving them around, it quickly starts to get really, really painful. And in fact, for the longest time, we had a better tool to deal with this, and then that name is called version control system, right? This is exactly a tool that's designed for managing changes and then keeping track of history. So those tools end up reinventing the version control system on its own, trying to create this pre-tested commit feature. So I think a better approach, and that's becoming more and more, I guess, that is realistic in many environments, is actually create a commit before you test. It's just that the Git is primary example of this, but it's just that you create a commit in a way that doesn't block others. So in distributed version control system, this is pretty obvious, right? The act of creating a commit and then pushing those changes to elsewhere is inherently decoupled. But even with centralized version control system, like let's say Subversion, you can still do things like this by, say, using branches. So you just create a commit, but you do so in a place that doesn't affect others until Jenkins come in later and verify that your changes are good. So that's why I think this term pre-tested commit is a bit of the misdemeanor, that it should really be called what I call as a validated merge. Because in my mind, what Jenkins does is it takes a commit that you already created. It's just that you're not sure about the quality of it, and so it takes that commit and then merge it with the current tip of the repository, and then verify that, and then push the result. So what's really going on here is the fact that you're validating, you're merging the changes with the validation that comes from the running of the test. So I think this practice really first emerged in the Git, because I guess that's where things like this was most natural. People had this, the distributed version control system makes this very easy. So the originally, I think this practice was most developed in the Gerrit and Jenkins and Git combination. So the Gerrit is a code review tool for Git. Does any of you use Gerrit? Okay, so all right, so two of you. So yeah, so it's a code review tool for Git, and then so someone from Sony Ericsson thought, well, this was originally a code review tool, so having other people look at that. But what if we treat Jenkins like just another reviewer? So he doesn't understand the code in any meaningful way, but he can run the test with that code. And if the test will look good, then this reviewer, this machine reviewer, would give you this +1, the sign of approval. And then Gerrit comes with all these workflow control systems. I guess that's a part of the code review. So when enough people send in their approval, it will merge the changes, push to the repository, and then do all kinds of other nifty things that makes it workable as a kind of the validated merge system. So what happens with this kind of scheme is, well, let's say you got those 3 commits in a repository that's replicated in all places. So you got the master repository that contains, so this is where the team would pull changes from. And then you get this Gerrit that's sort of, you can think of it as like a gatekeeper. It is the one that takes all the kind of potentially broken changes, but it's sort of controlling the access to the real master upstream repository. And then on the left-hand side, you got your own development computer. So, you basically hack the code, and then you create a new commit. And then instead of pushing that to the upstream, you push that into Gerrit. And so the Gerrit and Jenkins collaborate behind the scene and see if this test is actually good or bad. And if it's validated to be good, this change then gets pushed into the master. So it's sort of, again, it's acting as a buffer so that the changes that failed the validation wouldn't hit the master repository. So, so let me show how that works for you. So here I'm running a Gerrit server on. So the Gerrit is a Java application that's developed by Google guys, I think. And then it's used in pretty large scale in Android. So this is its UI. Right now there's no, so these are the past reviews. It's in this case, I guess it's just me pushing things and letting Jenkins test it. And this is my local Jenkins instance. But that's not what I should be seeing. sorry. Makes me a bit nervous. Yeah, and then I got this, another. And then I'm running this Jenkins with Gerrit plugin. So we should be seeing this. It looks like I was starting a wrong instance of Jenkins. Yeah, so this, like I said, this is available as a plugin that's called Gerrit Trigger plugin that you need to install. And then there's a few configurations you have to do to tell Jenkins that, for example, where is the Gerrit servers and so on. So those configurations needs to be done up front a little bit. And then this is also where I specify the workflow process. So in this case, I'm not actually interested in doing a code review per se, but I'm only interested in validated merge features. So I give this, I said, if the Jenkins is successful in building things, I give this 2, meaning +2. I guess the +1, -1 comes from this Apache community way of voting things. So the +2 meaning overriding OK vote. So as soon as this comes in, everyone else's comment doesn't matter, and then it just gets pushed into the upstream. And so here I have a job. So I have let's see. So yeah, I have a job configured that does the actual validation. And the only trick, so this got the Git repository that's specifying. So this 28080 is from Gerrit. And then all I have to do essentially is there's one advanced section that specifies this strategy, meaning like how does Jenkins decide what to build? So this needs to be set to Gerrit trigger, but that's basically it. And then I can specify whatever processes that I choose for doing the actual build. So in this case, I'm not really doing anything interesting but running a shell script. But you could imagine like running a full build, and not only just running a test, but let's say integrate that with code quality metrics. So with other plugins, you could, for example, configure that there be no new find bugs errors, or like you have to have a coverage that's going up, not going down. So you could use those things as a criteria. And it could take some time to do all these validation, and the people don't really care that much because as far as people are concerned, once they make a change and push that to Gerrit, that work is over. And so even if the validation process takes 1 hour as opposed to, say, 5 minutes, that's not much of a problem. So, so that's all I need to do in terms of the configuration. And so to illustrate, yes, it looks like it's cut on the left, which is a bit painful. So I have 2 workspaces here. So to simulate what like the developer see versus what another person in the team would see, I have these 2 workspaces, and so the one in red is from Alice, another hypothetical coworker of mine, and then on the blue prompt, I'm going to be working at Kohsuke, who's going to make changes. Right? So what I'm going to do is, so I already have a checked out workspace. So I'm going to touch the build script and then hello from Jax, and then make the build fail by exiting non-zero exit code. So I implemented awesome feature. And then, so now I'm going to push this to the origin. So the Gerrit has this little bit weird, wait, what did it do? That doesn't look right. Yeah, because it didn't, oh, sorry. So let me try this again. So the Gerrit has a little bit of the magic between rest going. So it's a bit picky on me specifying the branch name. Let me change. Oh, another change. Yeah, so in the last commit, I ended up bypassing the code review because I'm also administrator, and so I have this permission to do so. But here I did manage to create a review. So I did a push. So what I actually have done is to push the branch of the master to this magic ref called refs to master. So what that does is it indicates to the Gerrit that I'm doing a review. So if I now go see this guy, it should be already tested. So yeah, so the review 30 gets created, and this has all kinds of details about the changes that I created. Because it's a code review system, it expects people to actually see the change, like here. So these are the actual diffs, and then we can see what those things are about. But more importantly, so the Jenkins noticed that there was a new code review created, the review number 30. So you see that on the, I guess, on the menu here, there is a review from build 30. And I made the changes so that the build script would fail. So it runs my changes, and then it failed it. And then so the Jenkins, acting as a reviewer, post a comment on the ticket, on this review, I'm sorry, and then reporting that it failed. So in that way, people get the feedback about the failed build. And then often in places where people do the actual real code review by humans, they often defer that until at least Jenkins should chime in, because if the code is broken, there's not much reason in spending a time on looking at the code, right? Because it's obviously bad. So it's helpful in that way. So just to complete this workflow, so while this potentially broken change was being worked on, now if I switch to Alice, another coworker, and then if I pull from master, I think it's, and obviously I'm not going to see a bad change, except the one that I wrongly committed earlier. And so the other people in the team is protected from the failure. So now let me come back to the Kohsuke, and then I'm going to edit the script again. Good afternoon. And then fix, added greeting, something like that. And so, oops, why did it create? That's not, it's not supposed to create a new review there. I am not sure. Oh. Oh, this doesn't look good, actually. Oh. Sorry. Yeah. So okay. So I guess so. The reason, well, this is a bit of a mess. So what I was supposed to do was actually not, instead of adding this dash m, which overrides the messages, I needed to keep it. So that's why I guess I ended up creating new reviews. But what I actually wanted to do was to update the original review. And then it will, so I can push a new patch into this existing review, and then Jenkins should revalidate the change, and then it will accept it. But since I kind of messed up the commands, let me just abandon all these changes. And then what I'm going to do is reset to origin master, and then it's just going to fix that. Fix the broken build. And so by ignoring all the other earlier guys, if I do the 33, and so this should be building now, if it hasn't happened already. So now it's, I guess, review 33 was successful, and then so this change automatically gets should be merged, except it didn't happen. Or to a path conflict. Okay, so I guess it wanting me to manually merge the stuff. So what? Okay, so this time I have to force the push, I think. Anyway, so this was a, oh, come on. Upload merges. This I'm not sure. All right, well, so clearly this is not as what I intended, but I kind of have to. Yeah, so just, I guess just to show what was supposed to happen. So in this case, it was failed to automatically push because I had this merge conflict, but if that wasn't the case, then it will automatically push the changes, and then so that the other people can access it. And so that was the point, supposed to be the point of this demo. You know, I guess the highlight that I wanted to point out was the fact that with the distributed version control system, things like this is really easy. And then obviously, I think the code review itself is kind of getting attraction. So if that's what you're thinking about doing, this is another great way to combine them all. But at the same time, I think there's a bit of a problem in this having the server set up correctly. The Gerrit is not, in my mind, it's a bit tricky to set up. And it also wants to, the way we do things, at least in code review, I guess, the fact that the Gerrit being a code review tool makes its sweet spot a bit different from what we expect in the pre-tested commit tool or the validated merge tool. So, for example, in Gerrit, they expect you to have a, so let's say you worked on a branch, the feature branch that has like 3 changes. So you made a one logical change that's split across 3 changes, but maybe because one is in the utility code, another is in the client side, and the third one is on like a server side. And so if a single change consists of those 3 commits, the Gerrit wants to review every single one of them separately. Because if you're doing code review, I guess that's what makes sense. But when we are doing this for the validated merge feature, we don't really care if the tests are broken at some early stage. You know, often for you to get from one good state to another good state, you have to go through some unstable state. So this isn't unheard of to have this intermediate state that doesn't pass the test. But the Gerrit wouldn't be happy about that, and then so it wants someone to manually override this failure and then merge that in before all these successive changes, which are assumed to be dependent on this guy, can go into it. So this notion of one commit and one change review is kind of tricky if you're especially thinking about things like feature branch, you know, which does contain almost by definition multiple changes. So that's a bit painful, at least in my mind. And also, I guess, my failing the demo is another case in point that when you're kind of working against the system, it could get into painful state. So I thought, well, you know, it's great that you can do with Gerrit, but I thought we should be able to do this more easily just for the purpose of validated merge. So I created this another, I guess, mode of operation where you can just have Jenkins acting as a gate, not Gerrit. And so what Jenkins does is, well, developer would just push changes into this gate repository, and then the Jenkins would notice the change in there, and then pick up the branch from the upstream, do the merge, run the test, and then if the result is good, they push the result. So basically, it's doing the same workflow as Gerrit was, except using Gerrit entirely in Jenkins. So for that, let's see. So let me start another server that has a different set of plugins here. And then let me switch to a workspace. So in this, I don't have any extra plugins. I guess aside from the Git plugin, that is, which should be very obvious. And but the tricks that I do here is I specify two repositories because one is a gate repository that contains potentially broken change. The other being a master repository that's, I guess, the team central repository, right? And then I am telling Jenkins to do the merge down here in the advanced options. So I'm telling Jenkins to do the merge for the build. So I'm building this gate master branch in the gate repository, merge that with the origin, the master branch in the origin repository, and then that's what I'm going to do the build. And then here's the actual build process. Again, this is whatever thing you want to specify. And then eventually, I use the Git publisher. So this is the one that pushes changes to the upstream. So I only want to push the changes to the upstream if the build is successful. And then I'm changing the result. I'm pushing the result of the merge. Right? That's the state that becomes a new head. And that's it. So I guess, and combined with the post commit and post receive hook so that I can do the build right as soon as the new changes gets pushed. So, so let's say here, let me make some, oops. So as a developer, I pull from the upstream, I guess, the origin meaning the team repository, and then I'm going to tweak the test so that, let's say, make this hang. Making this hang. And then, so here I think it's a little bit more obvious what I'm doing there is that I'm changing the, oops, I guess pushing the changes to the gate. And so this triggers a new build. And so that contains the change that I just made, meaning it's hanging. So while this is hanging, again, I can go back to the Alice. And then here I can see that the change that I made is not yet reflected, I guess, which is the point, right? Because we don't want to have other people see the changes that haven't been tested yet. And the Alice might be making changes as we go. So actually, this can create a merge conflict. So that's another change from Alice. Changed by Alice. And then so notice that Alice isn't using a validated merge feature. So she's going to push the change right away to the master. And that's fine, right? I think the part of, I guess I failed to mention while I was talking about Gerrit, but another problem in Gerrit is that it wants to own this central repository because it wants to be the gatekeeper that sees every incoming commit to it. But in most of the places, I think this master repository is controlled by the corporate IT, or the GitHub, or some places that outside your control that you can't easily replace. And the fact that it needs to replace this central repository makes it difficult to use this practice on your personal basis. In other words, you have to convince the entire team to switch to this model before you could gain the benefit, which I think is a bit harder fight. Whereas in this scheme that I'm showing currently with Gerrit, Jenkins without Gerrit, I can do this by myself without telling anyone else. No one else needs to change the model. They don't even need to know that my changes are coming through Jenkins. So I think that makes it a lot more easier to start deploying this process without fighting internally between different teams. So what I wanted to do is back to Kohsuke. So I made a bad change that didn't pass the test. It hung the build. But now I could fix that. I'll fix a hang. And notice I'm not amending commits here. So I did go through this one intermediate bad state that didn't pass the test. But as long as I eventually get everything right, like in this case, it will do another build. And did it already happen? yeah, okay, it already happened, it looks like. I guess it was too fast to show up in the UI. And then it did the merge, and then it pushed the results. So if I go back to origin master, wait, what's that? Oh, did I push? Okay. Yeah, sorry. So if I look at the entire commit tree, I guess the way it looks like is, so Alice made a change. So this was the baseline before we started the demo. I started the demo, and actually, so let me, yeah, and then this is a commit that Alice made while I was struggling with this change. And so this is my original change that was broken, and then this was my second change that got everything right. And then this was the merge by Jenkins that that created the whole result. I wish I could show who made the commit. Actually, yeah, this might be a bit easier to see who did what. Yeah, so it's the Jenkins who did the merge, and then so so that you can see who did what in what order. So eventually, I guess Jenkins does merge everything into the shape so that things will back into the same trunk, but at the same time, there's some temporary variation to how this works. So, yeah, so again, the reason I like about this little better than the Gerrit setup is that you can do a lot more. You can do a lot more between the build and push. So here I only used one job, but if you combine this guy with things like build promotion plugin, you can have a lot of processing going on between the time the change comes in to the point in which it gets pushed. So you can have a build, you can have it deployed to somewhere, and then you can run some client-side tests. And then only after all these 3 jobs are completed, you can have it change pushed back to the server, for example. I mean, have the changes pushed back to the central repositories. And then you can do the exact same thing with the feature branches. Instead of having personal code and changes tested one by one like that, if you wanted to deploy it against the feature branch, you just have to come up with some naming convention to do it. And then again, the other thing being, you can do this by yourself without selling this idea to other people, which I always find tricky. And I think it's nature in Jenkins that these things start in bottom-up fashion, right? So this works better in that sense. But the way this is set up today, you need to have one repository per developer. So that's, I guess in Git, it's normal to have lots of repositories that's slightly different. But at the same time, if you're thinking about deploying this for everyone in your team, this kind of gets somewhat painful. And then likewise, I've used one job for one developer, which again, for the same reasons, doesn't scale. I mean, in a way, this is a benefit because that was the reason why I can do it without affecting other people. But if you like this so much that you want your team to convert to it, it's start to get a little bit painful. So there's a number of variations. I guess this is somewhat in the nature of Git, but there's a number of slightly different ways to achieve very similar results. So one of the flavors of doing this is like instead of different repositories to stage the changes, you can create branches to stage the changes. So instead of having your changes pushed to this Git repository, you just push the changes to the master repository, except in some known branches that's supposed to contain these half-baked changes. So let's say you can come up with naming conventions like personal/Kohsuke, meaning whatever whatever changes that I'm personally working on, or you can say like feature/Hoover, indicating this is a Hoover feature, and then we can instruct Jenkins that whatever changes that show up in these branches get automatically built and tested in this scheme. So that's what I wanted to quickly show to complete this part of the demo. So here, it's really the same thing, but now I only have one repository, and then here I have this branch specifier. This is where you use the magic. that I said, anything that matches this branch, so the personal/star, so anything personal/Kohsuke/Alice and so on, they get automatically built. And again, I'm not sure why it's. And then in the advanced sections, we should be able to see that I'm always merging that against the master branch before the build, because we want to test the state that's being built. And then do the testing, I guess as usual. It's just a test script there. And I'm going to remove this guy. And in the end, I'm doing the same push. And then the result, I push the result of the merge only if the build is successful. So that's that. So here, let me switch the, and then so I'm going to bring the system back to state with master, and then changes this code. And so, well, hello from Jax. And then so I'm making the build fail, implementing a new feature. And here I'm going to push this, my personal branch, personal Kohsuke. Yeah, so then this, so yeah, so this is the build that resulted from my change, and it failed because, yes, it contains my change and it failed. But the good thing about this time is that even though Alice isn't affected, she can still see the changes. So if let's say like I headed back home as soon as like I pushed the changes, which often happens in the Friday evening, right? You feel like you're done with the changes, so you push things up and you head home, and of course those changes aren't working. But I guess the worst version of it is like, when I do this right before I travel to, let's say, Israel, right? So for a week the repository is broken. But now Alice, so I did this from the Alice workspace, but she can see that she can see my changes. It's just that it is not in the master, right? Because so the ability for Alice to make progress isn't hindered, but she can see the changes, and she can even push the additional changes to fix stuff up into my branch. Right? So that allows people to collaborate among failures, and I think it's very convenient for feature branches. But at the same time, I think the Alice is in her branch, so I'm going to make yet another progress. More likely, she has some other busy things to do, so change by Alice. And then I'm going to push, Alice is going to push the her personal branch. And then that should result in another test being run and stuff successful. And then I can come back to me in the meantime. Let's say I get the email from Jenkins telling that the build was broken. So I'm going to fix it up by saying, fix the build. And then, oops. And then I'm going to, Then I'm going to push the Kohsuke's change in it. And then the whole thing gets, again, tested and merged, and then that merge result triggers another build and so on. So eventually, if I pull the changes all from the upstream, let's see here. So here's, so what happened here is that, so this is the first change I implemented, and then in the second I implemented another commit as Alice, right? And then that got merged by Jenkins, and I worked on the second commit on top of this first failure to fix this problem, which then got merged into the whole thing. So you can see that it creates this lattice structure. There is a slightly different type of branches that the people are working on, but as Jenkins merge them together, you end up kind of consolidating into this single view. So by periodically making sure that your work is synchronized with the master, you get to so everyone gets to work on changes, and then they can all delegate the test execution to the server, and then the whole thing will never, the master branch will never break. So I think that's what we wanted, right? So that's that. Yeah. So so here we got away with just having one repository. So if someone is interested in doing this setup once, everyone else in the team would benefit without doing any extra things on their side. And also, it's this eventually consistent model that I think is really useful. It doesn't demand that you have success in every single step. As long as you eventually make it work, you're good. And in all through, the system would make sure that the rest of the people would be protected from your harm. And this only uses one Jenkins job. Now, I guess the downside is that you tend to have more merges, so it's a bit more noisy in the repository. I think the people from Subversion background and so on, they don't want to necessarily see this large number of merge commits. So that, I suppose, is a potential downside. But it's also, I guess I'll leave it at that. But I think there's in my mind, benefits overweigh the cost of it. So that was about Git. In a way, it's kind of easy to do this with distributed version control system. But at the same time, I think still the majority of this world seems to be using Subversion, right? Actually, how many of you, do any of you use Subversion? All right, so this sounds like a lot more advanced audience. So in which case, I might, the rest of the talk might not make much sense to you anyway. But so the Subversion in most places, I think in the last survey I've seen, it's more like 50% of the developers are using Subversion. And so, in those version control systems, doing this kind of stuff is a lot harder. But but I eventually managed to write a plugin for Subversion that helps you with this validated merge. It's called the SPN merge plugin that you can install from the Update Center. So, what it does is it emulates the model that's similar to this multi-branch model in Git. So in this plugin, what you're supposed to do as a Subversion user is to work on your changes in your branch, and then let Jenkins notice that there's a change in the branch, and then it will automatically merge it with the master and things like that. So not master. I suppose in Subversion we call it trunk. So in trunk, the Jenkins acts as the only guy who makes the commits into the trunk, and then it only does so after it's validating the changes. So it sort of kind of works because the Subversion also has been improving in recent versions. So I guess just to recap, so these red arrows that's in the middle, these are all the changes, the merges, and then rebases that the Jenkins did. These black line indicate commits that individual developers do. All right. Yeah, it is a Jenkins plugin called SPN merge plugin. Because the name is a bit poor because originally there was a different tool called SPN merge that someone wrote in Python that did some of these advanced Subversion merging. So this code was originally written for that. And then in Subversion 1.6, they kind of integrated that feature in the core. So the name remained, but anyway. So this is the plugin that does similar thing for Subversion. And with the recent improvement in Subversion, like 1.6 and 1.7, this is becoming a bit more realistic. And so the only caveat here is that when you do this merge, this merge being pushing the change up from the branch into the master. The trunk. Subversion also demands that you do the rebase at the same time. So you kind of have to sync up the changes at the same time. But this is the only caveat you need to be aware of. And everything else, it kind of Jenkins and this plugin takes care of. It's basically just running merge commands and with the right parameter. Right, so what I'm going to show here is, let me switch to yet another instance where I have a separate spin merge. So here I checked out the entire tree, not just the trunk, but the entire trees in one workspace, just so that we can get away with one. So here, in case of Subversion, what I did was I created this job that looks at the master branch. I'm sorry, the trunk. I keep confusing the term. I apologize. So it's checking out from the trunk, doing the build, running the test, and so on. And then that's it. But the only trick is that I have this accept integration from Subversion feature branches checked. So this is the feature that comes from this SPN merge branch. So let's say I wanted to now work on the feature branches. So I can come in this feature branch thing, and then I can create a new branch. So let's say a branch name would be, say, Jax. Oops. Oh, I guess Jax already exists. So I don't know, July. And so we'll create a branch in the repositories. So if I do the workspace update, you see that there's a new branch created. And then it also creates a new job that manages this workspace and manages this branch. So let's say I'm going to now go into this branch. Yeah, this is all part of this SPN merge plugin. So I guess I find it convenient to do this kind of operation on the server because, like, I keep, when I was working on a large Subversion project, I kept forgetting to update the workspace to the latest state in the right branch to run the command, and then I end up creating this messed up state. If you notice that in the programming, you're lucky because sometimes they let you get away with it, and only much later you discover that you didn't quite branch off from the right place, and they got this merge shell, and then by the time it happens, too late, and so on. So I think this having a button on the server makes it rather foolproof. And so let me just make some make some change, some edits. From another change or something. So all these, this job is already set up to do the right things. As I was making commits, it will start building everything, and then, so that's what I wanted. So now I have this my CI job for my personal branch and changes being tracked and all that. And so now let's say I got to the state that I'm ready to integrate, and then so what I can do is I can come to this build that I want to integrate into the upstream, and then click this integrate to the upstream button, and then that would do all the kind of the merge and commits and stuff, and then so it will get pushed up to this stream. And then so this not only that, it provides this audit trail. So Jenkins noticed that the commit, so this act of merge would create a new commit in the trunk, right? And then so that trunk commit gets picked up by the base job that's building the trunk. So it notices that the change that's pushed into the trunk gets picked up by that build 99 of the guy. And or if I go there, it knows that this change that's merged in this commit came from my branch job. So it creates this auditability trail that's kind of handy. And also, if I wanted to, in case of feature branch, the other, or the personal branch, I suppose, the other operation that makes sense is, all the other people are making changes to the trunk. So when the time comes, I want to rebase the change from the upstream, meaning pick up all the changes that's made in the upstream. So I can do that by coming to this project top page and then click this rebase button. And here, I guess this is another benefit of using a CI server is that normally if you're doing this from Subversion client, you'll be doing it you'll be merging the tip of the trunk, right? But here, because we know that which revision is actually built and tested, so this was trivial enough demo that the current trunk tip is already built and tested and known to be okay. But sometimes, people working on the commits, the tip of the repository might happen to be not tested yet or might fail the build. So we could say instead of just picking up the latest version, we can pick up the last known stable version or something. And then that will, we can pick up the changes from there as opposed to just random version in the master, in the trunk. In this case, it actually noticed that because the last commit that came in the master is from this branch, so there's nothing to rebase, so it actually didn't create commit. But in general, that's the workflow. Now, so doing the rebase and integrating manually is only interesting to a certain degree, because the point of this is to do that automatically. Right? So here we could say, if let's say, well, if this is a feature branch, I suppose this might be actually what all you want, because you want to initiate this integration process manually, right? But if you're if you're thinking about using this as a validated merge style, what you want to do is to automatically integrate and automatically a rebase as necessary. So instead of doing it manually, I can click this integrate upstream upon successful build, and then in this way, every commit that I create gets tested, and if they're successful, it automatically triggers the merge operation. So let me delete this newly created file. I'm deleting the created file, and then if I do the push, if I do the commit, it will merge the changes, and then the changes show up in the upstream. I guess, where was it? Yeah. So this is the build that tested my commit. So it picked up the deletion to the file, and then I send up the changes to the master, changes to the trunk, and then so that went into the base 100, and so on and so forth. So if I update the entire workspace, you see that the file, the July file in the trunk is now removed because I merged that change once again. So I guess that's how this could work for Subversion. Mainly the fact that it works for Subversion in my mind is amazing enough, and so I was very happy with that. And it comes with a number of composable building blocks. So you can do this rebase and integrate, and then automation and manual execution and mix and match, I think is really convenient. So on the downside, I had mentioned that it does create a lot more commits. So there will be a substantial number of merge commits depending on how you use it. But I mean, in other words, but on the flip side, that's what's giving us the ability to do this automatic change propagation. So I suppose that's just a necessary price of it. So I think that's what I mainly wanted to talk. I guess the first point that I wanted to press was this isn't pre-tested commits, meaning you don't want to do the test before you commit. It should be the other way around, that you should be committing first and then let that test it. And then only after that you kind of propagate the change up, bubble it up to the point that the other team would see it. Yeah? So that's how you want to do it. And then I think it's very easy to do with distributed version control system. There's, in fact, no less than 3 ways that I showed you today here that have the different characteristics and so on. But it's also possible to do this in Subversion. And I believe recently someone in the community came up with doing this for ClearCase. And the Perforce also has a similar functionality, so you should be able to do things like that. So I think, I think the direction that we are seeing is that the different version control system needs to tackle this problem in different way. So the community is working on implementing those features now. So these are all available as open source plugins. So if you're interested in those, you can go to jenkins.ci.org, and then it's the Git plugin, Gerrit trigger plugin, and Subversion SPN merge plugin. Well, thanks very much for showing up, and I really appreciate that.